Practice exercise number 6 in your review exercise and speed drill booklet, page 7. If you'll go ahead and turn there. Review exercise number 6. And you might remember that when you're finding the speed of an object, you basically would take the distance that the object travels divided by the time it takes. Now, here in the United States, we use miles per hour as our speed, for instance, for a car or an airplane or something like that. So, for instance, let's just make up a problem here. If you were driving down the road and you drove 40 miles in 1 hour, we would say you were going how fast?
40 miles.
40 miles per hour. We would say the same thing if you went 80 miles in 2 hours. You would divide the 80 by the 2 and still get 40 miles per hour. Does that make sense? But it's important that the distance be measured in miles. And it's important that the time be measured in hours. Does that make sense? For instance, if you went 5 miles in 10 minutes.
You can.
5 miles in 10 minutes. Well, I'm supposed to divide the distance by the time, right? But 10 minutes, that's not an hour, that's a fraction of an hour. That's 1/6 of an hour, correct? So I would have to take the 5 miles divided by 1/6 of an hour. And it's a good thing we know how to work with complex fractions, isn't it? Because we know we never really divide fractions, we multiply by the reciprocal. So if we multiply by the reciprocal, which would be 6 over 1, we would get 30 miles per hour. Does that make sense? Questions on finding speed. We remember this from years past. All right, review exercise number 6. Go ahead and get started. Just 6 problems. When you're finished, put your pencil down this way so I know that you're done. pencils down, even if you're not finished. We'll take a look at these together, and Danielle was first. Danielle, if you were to travel 372 miles in 6 hours, how fast would you be going?
62 miles per hour.
62 miles per hour. For the next one beside it, if you went 860 miles in 2 hours, you would be going?
430 miles per hour.
430 miles an hour. For the next one, if you went 1,764 miles, not 1,760 yards, that would be a mile. Anyway, 1,764 miles in 36 hours, how fast would you be going on average?
49 miles per hour.
49 miles per hour. What about 787.5 miles in 3.5 hours?
225 miles per hour.
225 miles per hour. What about 12 miles in 30 minutes?
24 miles per hour.
24 miles per hour. 30 minutes becomes half an hour, so 12 miles divided by a half hour gives 24 miles per hour. And for the candy, if you traveled 1,248 miles in one entire day,
52 miles per hour.
good, change the one day to 24 hours, dividing at 52 miles per hour. How many got all the ones you did correct? All right, excellent. Right behind her, and you were correct with all of them as well, Hayden. So just a nudge faster, you got candy. Questions on this? Questions on this? All right, let me go and collect those from you. Pass those forward, if you would, please. And take your homework out. Looks open at page 137. Looks open at page 137. And you did a variety of problems that were in the homework section. I asked you to do numbers 1 through 6, 10 through 12, and 15 and 16. So let's see how we did here on those. Numbers 1 through 6, 10 through 12, 15, and 16. On page 137. Oh, Glenn. You sure you wrote a 132 and not a 137 and misread it?
Yeah, that's probably.
You did that in class yesterday, wasn't it? It was a 7 and you read it as a 2 or something like that. Oh, got it right neatly. This is why we have our elementary teachers teach penmanship, so we won't misread stuff like that. All right, let's take a look at these anyway. Number 1, you're adding a couple mixed numbers, and of course we can't add fractions, class, unless they have a common denominator. And the denominator 3, denominator 4, we need to turn into denominator 12. And when we add them together, what do we get for our answer, Michael? 12 and 7 twelfths. Number 2, what is that thing, class?
Proportion.
Proportion, 2 equal ratios. And we can clearly see, well, actually a couple ways. You could think of multiply the 5 by 6 gives you 30, so multiply the 20 by 6 gives you, class? 120. The other thing you could do, you could say this. To go from a 5 down to a 20, I multiply by 4. To go from a 30, multiply by 4, down to a 120. You could do that way as well. Or you could cross multiply. 5x equals 600, and divide by 5 to get 120. Any of those methods would work. Number 3, you've got to divide by the 6. And it doesn't go in evenly, so we're going to mush some bushels over to pecks and do all that division. What do we get for our answer there, Evie?
3 bushels, 1 peck.
3 bushels, 1 peck. Number 4, adding those together, we get more inches than we need, so we can take some of those inches and mush that over into a foot. What do we end up with here, Lexi?
52 feet and 5 inches.
52 feet, 5 inches. Number 5, 60% of 88. How do we set that up, Aubrey?
Multiply.
We multiply what?
0.6 and 88.
0.6 times 88 to get?
52.8.
52.8, very good. Number 6, how do I set that one up, Hayden?
0.3.
No, how do I set it up?
30 divided by 90.
There we go, 30 equals x times 90, but we divide both sides by 90, so we end up getting a 30 over a 90, but I would reduce that down. You can easily reduce it, class, by knocking off the zeros, but you could also divide that by 3 and end up with,
1/3.
which we know is what decimal, Hayden?
0.3 repeating.
0.3 repeating, and so when I move the decimal 2 places, I end up with
33 and 1/3%.
33.3 repeating, or 33 1/3%. If you happened to round it off to 33.3%, it didn't say to round, but oftentimes it will. How many got one of those answers for number 6? Questions on that one? Number 10, you are adding those two numbers, and the only requirement, they've got to have the same class exponents, and they do. So we can add them together, but our answer comes out looking wrong. So we have to change it up a little bit. What do we get for our final answer, Danielle?
1.57 times 10 to the 8th.
1.57 times 10 to the 8th. Initially 15.7 times 10 to the 7th, but that's too big. So we're going to move the decimal over to make it look right, and then we're going to make the exponent bigger and end up with 1.57 times 10 to the 8th. Number 11, we subtract, and again, we are initially going to get something that's just not quite right. We're going to have to change it, but what do we get for our final answer here, Lexi?
4 times 10 to the 2nd.
Good, 4 times 10 to the 2nd, or 10 squared. We initially get 0.4 times 10 cubed, but that's too small. So we're going to move the decimal to fix it and make the exponent smaller, 4 times 10 squared. Number 12, what is that thing, Michael?
Complex fraction.
A complex fraction, but we know a complex fraction really is just a division problem. So we're going to divide. We don't really divide fractions. We
multiply that to 6.
So if I saw this problem on a test, how would I write it down?
56 over 11 times 22 over 14.
There we go. And now we cancel some stuff.
The 11 and 22 turns into 1 and 2. And the 14 and 56 turns into a 1 and 4.
If you happen to know your 14 times tables, it is 1 and 4. If you didn't, maybe you saw your 7 times tables. Gives you a 2 and an 8. Even so, the 2 and 8 would then reduce to 1 and 4, or you just cancel the 2's with each other straight up, and you end up with what answer, Michael? 8 is our answer. Number 15, what is that number in scientific notation, Hayden?
4.27 times 10 to the 3rd.
Oh, Aubrey.
4.27 times 10 to the negative 3rd.
Remember, little bitty numbers, negative exponents. 4.27 times 10 to the negative 3rd. Don't miss that on the exam tomorrow. 4.27 times 10 to the negative 3rd. Number 16, what would that number be in standard form? Back to Hayden for redemption.
610,000.
610,000 is correct. Was anyone perfect on the homework? Wow, several people. Questions at all on the homework? Any questions on the homework? Let's quickly review over some units that you'll need to have memorized. Hopefully you've been working on these. We already took a test over it, so should have done a lot of work for it leading up to that test. But let's go ahead and review some of these. Just call these out as we get to them. Let's not start there. 7 days in a week. 24 hours in a day. 60 minutes in an hour. 60 seconds, good guess. 2,000 out there pounds in a ton. 16 ounces in a pound. 8 quarts equals 1 peck, or 1 peck equals 8 quarts, depending on how you want to phrase that. 4 pecks in the bushel. 16 fluid ounces in the pint. So remember, a pint is a pound. So a pound of water would be 16 fluid ounces, or a pint of water.
8.
That's the 8. 8 fluid ounces in a cup. A cup is half of a pint, so it makes sense we'd have half as many fluid ounces.
3.
That was the 2.
No.
2 tablespoons in the fluid ounce. You're thinking of the 3 teaspoons in the tablespoon, but 2 tablespoons in the fluid ounce.
4.
4 quarts in the gallon.
2.
2 pints in the quart.
3.
3 teaspoons in the tablespoon.
2.
2 cups in the pint.
1,760.
1,760 yards in the mile.
5,200.
And good guess, 5,280 feet in the mile.
36.
36 inches to the yard. 3 feet to the yard, because there are 12 inches to the foot.
1,000.
1,000 years to the millennium. What is it, Hayden?
100.
Yeah, it's 100. You got it. 100 years in the century.
20.
20 years to the score,
10.
10 years to the decade, of course,
12.
12 months to the year,
366.
366 days to the leap year, 365 days to the year,
52.
about 52 weeks in the year,
7.
or 7 days to a week,
24.
24 hours in the day. Make sure we know those very well. You're already on page 137. I want you to look back to page 136. Page 136. And work on numbers 25 to 30. 25 to 30. 25 to 30 there on page 136. Aiden's finished, Daniel's finished. All right, number 25, 18 feet. How many yards, class? 6. We divide by 3. Divide by 3. 18 inches would be half a yard, but 18 feet would be 6 yards. Number 26, 20 pints. How many cups? 40. Remember, it takes 2 cups to make the pint. The pint is big, the cup is small. Or you could use dimensional analysis. You could put your 20 pints over 1. You're like, I don't remember which one's big and small, but I know there's 2 cups to a pint. Well, then put the 2 cups on the top and the pint on the bottom, and just multiply. And then it shows you to get the 40. 8 decades, how many years? 80 years. 80 years. Speaking of dimensional analysis, 120 pints, let's put that over 1. What do we know about pints, class?
Pints, 2 pints equals a quart.
2 pints is a quart. So we could put the quart on top of the 2 pints. That cancels the pint. We're not quite to gallons yet.
4 pints equals a quart. 4 quarts equals a gallon.
4 quarts is a gallon, so we can put the 4 quarts on the bottom and the gallon on the top. And when we multiply across the top, of course, we just get 120. Multiply across the bottom, we get
8.
So we end up needing to take the 120, divide it by 8. 8 goes into 12.
4.
Once with 4 left over, 8 goes into 40. 5 times. So apparently 15 gallons should be our answer. Number 29, we don't need to memorize anything except one historical piece of fake news, class.
King Henry died.
And we're going to go from the Henry to the unexpectedly. And it's only moving the decimal a couple times. We end up getting 467. And then for the next one, we need to go from the milk to the died. Not the drinking, but the died, the first D. King Henry died is your deca. So we're going to go there and move in the decimal, what is that, 4 places we end up moving it to get? 0.20243 is our answer there. Anyone 6 for 6? Questions on any of those? Questions? All right, go on and do numbers 31 to 33. Those next 3 problems working with scientific notation, adding, subtracting. Just the next three, 31, 32, 33.
I did all the, I did the first 6.
Number 31, what do we get for our answer, Aubrey?
7.9 times 10 to the negative third.
7.9 times 10 to the negative third. Number 32, what do we get for our answer, Glenn? Good. Initially, 11.3 times 10 to the fourth becomes 1.13 times 10 to the fifth. Number 33, what do we get for our answer, Danielle?
3.9 times 10 to the 8.
Oh, you added. It said subtract. Yeah. Michael?
3 times 10 to the 7.
Good. 0.3 times 10 to the 8th becomes 3 times 10 to the 7th. Questions on those? All right, do 34 to 39, practicing with compound units. 34 to 39, practicing with compound measures. Let's go and take a look at these together. Number 34, initially when you add, you should have gotten 10 gallons, 4 quarts. But class, we know that 4 quarts is another gallon, so we should just get 11 gallons for our answer. Number 35, just subtract, and what do you get, Glenn? 6 feet, 7 inches is correct. Number 36, we can't just subtract this time, so we have to borrow. Take a minute from the 10 class, which gives us
105 minutes.
take a minute from the 10 to get 9 minutes. And that 1 minute comes over here to the seconds column and becomes 60 seconds. Plus the 45 I already had gives me 105 seconds. Now I can subtract, and we end up getting what for the answer, Hayden?
5 minutes, 55 seconds.
5 minutes, 55 seconds is correct. For the next one, we multiply and get 60 pounds, 72 ounces, but that's a whole lot of ounces. And there's multiple lobes within those ounces. How many ounces in a pound, class? 16. How many sets of 16 in 72, anyone?
4.
There are 4 of them. That's 64 of those ounces. Needs to come over and become an additional set of 4 pounds. For a final answer, Danielle, of 64 pounds, 8 ounces. Number 38, you just divide straight up and it works really great, really easy, Lexi.
4 miles and 6 yards.
4 miles and 6 yards, which is really nice because I don't want to have to bring in, sets of 1,760 over this way from your perspective, over into the yards column. Not all about that. But we're going to have to do that on the next one, right? The 4 goes into the 5 class 1 time, so we get 1 hour, but there's a leftover hour that becomes 60 minutes. Plus the 20 minutes we already had gives us 80 minutes, which can divide by the 4 to get 20 minutes. So our answer is 1 hour, 20 minutes. Anyone 6 for 6? Got them all. Questions on any of those? Do we need to see any of them worked on the chalkboard? All right. A unit relationship, and again, the book uses this term a lot. So just so that way, bless you, you're clear on this. A conversion factor is what we use in dimensional analysis. It is a fraction where the top maybe is 3 teaspoons and the bottom 1 tablespoon. They match each other. Okay, that's a conversion factor. A unit relationship is kind of the same thing, but it's not written as a fraction. It would just be 3 teaspoons equals a tablespoon. Okay, so for instance, what we were just practicing with these, this is a unit relationship. If you put one on top of the other, you have a conversion factor. Do you understand the difference there? Just in case you see that on the exam tomorrow. So as we look at number 40, it says, what unit relationship should be used to convert from tons to pounds? So you just think to yourself, well, what do I know about tons and pounds? And you write the fact out. For number 41, what 2 unit relationships are needed to convert from seconds to hours? So you're thinking of 2 relationships in there. Then you got a little scientific notation practice, 42 and 43. Do that little mini section there, 40 through 43. It's like, I don't know what was on page 132 anyway. Let's take a look at these. What unit relationship should be used to convert from tons to pounds? Michael?
1 ton equals 2,000 pounds.
1 ton equals 2,000 pounds. Number 41, what 2 unit relationships should be used to convert from seconds to hours? Lexi?
60 minutes, 60 seconds equals, 60 seconds equals 1 minute, and 60 minutes equals 1 hour.
Perfect. 60 seconds equals a minute, and 60 minutes equals an hour. Number 42, what is that first number in scientific notation, Glenn?
6.578 times 10 to the 6th.
You've got to learn to write your sevens better. 6.578 times 10 to the 6th is correct. I would say one of these days you're going to get burned by that, but you already got burned by that. All right, how about letter B? How would we write that in scientific notation, Evie?
2.34 times 10 to the negative.
Good, 2.34 times 10 to the negative third. Number 43. How would I write that first number in standard notation, Aubrey?
85,000.
85,000. And how about that second number in standard notation, Hayden?
0.072 times 8.
Yeah.
0.0721.
0.0721 is correct. There we go. All right, questions on those? Questions on those? So obviously, so last year was my first year teaching this when I wrote the curriculum for this. And we were doing everything on Zoom for these review lessons, and I guess I got my timing way off because we're done with the review. And we've got a bunch of time left. Of course, yesterday we went way over. So next year, I'm going to do things differently, so I balance the two lessons. But what that does give us, and maybe this is a good thing, is about 15 minutes of anything you feel the least bit nervous about. We have gobs of time where I can make sure I answer your questions. We don't even have any math homework tonight for me to have you get started on. So really, these next 15 minutes are, I'm a little shaky on long division. I'm a little shaky on fractions. I'm still shaky on compound measures. I'm still a little confused on integers and rational numbers and natural numbers and that, whatever it is that you're iffy on. So we're going to flip through the book together. All right, so I want you to go all the way back to the beginning of the book. And we're just going to kind of turn through here and make sure that we are strong on everything since we have 15 extra minutes due to my poor planning. Hey, at least on a positive note, we're not going to go over today. Place value. Are we good on place value? Or rounding numbers. We have had a few issues with rounding numbers. Does anyone want some practice with rounding numbers to different digits? And you will probably have one rounding thing on the test tomorrow. Anyone need to get more practice with rounding? Obviously, you look at the place value. So if I say round to the hundreds, you're going to look at the hundreds digit. But then you're going to look right behind it. And if you have a 5 or bigger,
5 or more, base the score. 4 or less, let it rest.
What she said, bump it up, right? And if it's not 5 or bigger, if it's 4 or less, knock it off and it becomes zeros. Okay, do we need practice with that?
Oh.
All right, addition. We good on addition?
Yes.
Subtraction?
Yes.
All right, there's some terminology there we were rusty on yesterday, by the way. Multiplication. Do we need more practice with long division?
Please no. Yes, please. No.
Yes, please.
No.
Hey, this isn't a time to be selfish. If there's one person who needs the practice, we're going to take the time to practice. All right, so let's do this. Let me come up with one that actually works out. So I'm going to cheat and use a calculator instead of just making up random numbers because that can be really disheartening.
You gotta say your answer circled down.
All right, so let's do this together. Just have out some paper or find a blank spot in your book somewhere that you can fit this in if you write small. We want to divide 314,080 by 32. And I said because we don't know our 32 times tables, normally, class, we're just going to look at the first digit. And normally over here, I'm only going to look at the first digit as well. And so what I'm going to do is I'm going to also kind of round the number in my mind. There's a 2 after the 3. Should I be thinking 4 or should I be thinking 3?
3.
I'm still going to think 3. And normally I would ask myself, how many times does 3 go into 3? And we would normally answer myself once. Except, if I put a 1 right here, 1 times 32 is going to be 32. It's going to be a little bit too big. So evidently it doesn't go in once. So then I'm asking, okay, how about 3 into 31?
0.
Well, 31 technically goes in 10 times, right?
Oh, well.
But we can't go that big. The biggest we can do is
9.
9. So we'll put a 9. Here's 1 digit, 2 digits. We're going to put the 9 over the 4. And again, you don't do any multiplication off to the side. That's a big waste of time. And you're prone to make mistakes if you do it. We're going to multiply the 9 times the 32, starting with 9 times 2, class. 18, and then we'll carry the 1. 9 times 3 plus the 1, 28. We do all of that in our head, nothing off to the side where we're going to screw something up or forget to carry something over. And then we subtract. Borrow, make this a 0, make that a 4. 4 or 10. 14 minus 8.
6.
And borrow again, 10 minus 8.
2.
And of course 2 minus 2 is 0. We bring down the 0. Then we ask ourselves, how many times does 3 go into 26? Because I don't know my 3 times table, or my 32 times tables, but I know that 3 goes into 26 8 times. So we write an 8. 8 times 2.
16.
Carry the 1. 8 times 3 plus 1.
25.
And we subtract. And we borrow, and we get
4.
4. And of course the other 2 numbers become zeros. And then we bring down the 8. And we ask ourselves, how many times does 3 go into 4? And it goes in once. See, we simplify stuff. We find the easy way. We don't use 32, we just use the 3. And of course 1 times 32 though. 32. And we subtract and we get
16.
16. And we bring down the 0. And we ask ourselves, how many times does
3.
No, how many times does
3
go into 16? Answer? 5 times. And we multiply 5 times 2.
You get 0.
10. Carry the 1. 5 times 3 plus 1.
16.
16. But, yeah.
Oh no. That's not a good one. Nate?
If we have 578,817 being divided by and 881. Again, I don't know my 881 times tables, but you don't gotta know your 881 times tables because we do things the easy way. I only look at my first digit. And over here, I just look at my first digit. Well, okay, let's put them together. But because there's an 8 right after this 8, I'm really gonna be thinking, class, 9. How many times does 9 go into 57? And the answer is 6 times. Now again, I've got 1, 2, 3 digits here. This is collectively 1, 2, 3. I'm going to put the 6 right over here. What's the problem?
Not that. It's supposed to be a 7.
What do you mean it's supposed to be a 7? 9 goes into 57 7 times? Let's go with 6 here. We may, and here's the, by the way, here's the nice thing. Maybe we're wrong and it should be a 7. Then we'll catch that because when we compare, our number will be too big. But let's just try 6 for now. 6 times 1. 6. 6 times 8. Write the 8, carry the 4. 6 times 8 plus 4. 52. Again, we don't need to do any of that off to the side. You're not going to be any more accurate off to the side, but you're going to forget what number you're supposed to have up here. We subtract 8 minus 6.
2.
8 minus 8.
0.
7 minus 2.
5.
Is 502 smaller than 881?
Yes.
If it weren't, we'd go to a 7. Since it is, we're going to ride with the 6, and we're going to bring down the 1. And then I ask myself, be careful, think here, how many times does
9.
9 go into
50.
50? Answer?
5.
5 times.
5.
So we write 5. 5 times 1.
5.
5 times 8.
4.
Carry the 4. 5 times 8 plus 4. 44. Nothing done off to the side. We're doing this the easy way. And we're borrowing from the 2, making that a 1. 11 minus 5? 6. 1 minus nothing. And borrow again here. And 10 minus 4?
6.
I got a 616. That's still smaller than 881. We're still good. We bring down the 7. How many times does 9 go into 61? Answer?
7.
7 times. Well, not quite 7. But I know if I only did 6, I'd get this. Let's try the 7. And if we're wrong, we go back to the 6 and we get a weird decimal, all right? 7 times 1.
7.
7 times 8.
56.
This is looking good. Put the 5 here. 7 times 8 plus 5. 61. And we're done. Danielle, does that help to see? It's just a very consistent, repeatable, make it easy by only focusing on first digits. Makes life easy. Does that seem better? All right, any other questions with long division? All right, let's move forward then. The number classification, top of page 8. Number classification. Rational numbers, anything that can get written as a ratio. That includes decimals and fractions and integers and whole numbers, natural numbers. All those are rational. Integers are special because you get rid of the fractions and decimals. Whole numbers are even more special because you get rid of the negatives. And the natural numbers are even more special because you get rid of 0. But all of those are rational. See the line between rational and irrational? All those numbers on that list are rational. It's just some are extra special because they're integers. Everything in the natural and the whole are all integers as well. Does that make sense? They're not separate, they're included. Then whole includes the natural and the zero, and the natural just that. We good on those? Anyone want me to like throw random numbers on the board and see what they are?
Sure.
You do?
Sure.
Is that a yes or a no?
Yes. It's a sure. Yes.
Do you want help or don't you?
I got
Yes,
it.
you got it. Then you don't need help. Do you need help or not need help? I'm willing to help if you need it, but I don't want to waste time if we don't need help.
No, I'm good.
You're good. Are you sure?
No, I just wanted to say sure.
Strange child. All right. Absolute value, remember, you ignore the negative sign or the positive sign. Okay? It says how far it is from 0. Remember, a positive is always bigger than a negative. Okay? Even if it's like, you know, positive 2 and negative 63,000, the 2 is still bigger. In fact, it's way bigger than negative 63,000. Bless you. Oh, we have had a little bit of trouble comparing decimals. If we had like a 0.7305 and a 0.74 and a 0.712683 and a 0.7. Which of these is the biggest number, class?
7.74.
The 0.74, notice they all have the same tenths digit, so you can't really compare that. So you go to the next digit. I've got a 3, a 4, a 1, and technically this is a 0. Well, now I can compare. So the biggest is here. What's the smallest?
7.
The 0.70 or 0.7. The second biggest
0.73.
and the second smallest.
0.71.
But what if I also had a 0.73024? Which of these is bigger?
5. The one with the 5.
The second one.
The lower one, right? Because these digits all match. You're actually going to have to compare right here. This is the first digit that's different. This is bigger. Does that make sense? Okay. Factors. Oh, divisibility rules. Make sure you know those, right? If the number's even, it's divisible by 2. If the number ends in 5 or 0, it's divisible by
5.
If it ends in 0, it's also divisible by
10.
If it ends in double 0, it's always divisible by
100.
4 and 100. Or if the last 2 digits are divisible by 4, it's divisible by 4. But what's the rule for 3 and 9? What do you got to do?
It has to be
Add all the digits together and see if the sum of the digits is divisible by 3 or divisible by 9. And then 6 is kind of a double rule. For a number to be divisible by 6, it has to be divisible by both
2 and 3.
2 and 3, right? And we have, of course, our prime and composite numbers there. Prime factorization, there's division of primes if you like that. Consensus here seems like most people prefer the factoring tree. But you know, some people like the division of primes. So they're dividing by 2s until they run out of those, and then dividing by 3s until they run out of those, and then 5s until they run out of those. That works as well. Anyone want practice prime factoring? All right, anyone want some more practice with, well, they have exponents on the next page. We won't get ahead of ourselves. I assume we're good with bases and exponents and whatnot. We good with that? Okay. Negative exponents, we feel confident with those? What does negative exponent mean? Reciprocal. So if it's under 1, put it up top. If it's a normal number, put it underneath a 1. Gcf Lcm, do we want some more practice with that? We've had some trouble in the past. Any questions?
I think we got it.
Got it now? We've done enough of it at this point? All right. So remember, which one's the contest?
LCM.
LCM. And then for greatest common factor, you're looking for what is?
Matching.
What matches, what's shared, what's common. Fractions, reducing, common denominators. Any proper to improper to mixed to improper. Any of that we need help with? We good with fractions? Did you ever think you'd say that? We feel confident with fractions? Are we sure? All right. Ratios, proportions, some terminology to know there, right? Antecedent, consequent, means and extremes, stuff like that there. Any questions? Ratios, proportions. Let me give you one where you have to cross multiply. Something obnoxious like 4 is to 5 as 7 is to x. At your seats.
Why?
To give you practice cross multiplying, that's why. Do what? All right, what do we get, class?
8 and 3/4.
8 and 3/4. Right, we cross multiply the extremes to get 4x. Cross multiply the means to get 35. In class, we know that the product of the means equals the product of the extremes. And when we divide away the 4, 4 goes into 35 8 times with 3 left over, 8 and 3/4. How many got that? Any questions? Question, Evie? Alright. More fractions, adding, subtracting, multiplying, dividing. Sure there's no questions? Okay. Fraction decimal equivalents. Those would be good to know. But if you don't know them, how can you make a decimal equivalent?
You divide it.
Just
the
divide,
top
right?
number goes on 35.
How would you take a random, or not so random decimal like 0.732 and turn that into a fraction?
You take it because the number
The
number
over
of
a
digits
thousand.
is
Over
0.
1,000.
Right, this is the thousandths place. So you'd put it over 1,000, or you could say, make sure there's as many zeros in the denominator as there are digits. That works as well. You could reduce it down. I guess divide a 2 out of both, 500 in the bottom, and then what in the top?
That's a good question.
It is a good question.
666.
366.
Yeah, that's not
360.
bad.
Hey, we could divide by 2 again, couldn't we? And that would give me a 250 in the bottom, and
180.
183.
okay, I'm done reducing. There's my fraction equivalent. Right. Skip that. Percent, decimals, percentage base. Anyone want more practice with any of those?
You move the decimal 2 times. Got it.
Alright. Sure we're good with percentage base? Let's see, discounts. Discount is money you,
Save.
sale price is money you,
Save.
percent of change?
Change over original.
Change over original. What if I said that on his endurance run, Hayden ran 7 laps? And let's say Glenn had 20% more laps.
I could see that. I get.
What would be 20%? What do I do when I see 20%?
120.
Make it 120%, right? So multiply by 1.20. Or you could multiply by 20% and add it onto the 7. It's easier to go with 120%. But what if I say Glenn broke his leg and I made him run anyway, and he got 20% fewer laps?
You subtract that from.
You'd multiply by 80%, right? You'd subtract that. That takes us into chapter 2. We just drilled a ton of measures. We went over dimensional analysis. We feel good on dimensional analysis now? Y'all got this? Sure. Mixed measures, we did those. Metric measures with King Henry. Accuracy, precision will not be on the exam. Scientific notation will be. I feel like we're good there. Significant digits will not be on the exam. Operation, yes ma'am.
Yeah, the operations, page 87.
Page 87.
Yeah.
All right, so the addition and subtraction stuff. So if I had like
With the changing thing.
8.72 times 10 to the negative 5th, and I want to add like 3.04 times 10 to the negative 5th. Oh, we went past the bell anyway. Stay with me until we finish the problem, then we'll let you go. All right, so we just add it together, right? So, because they have the same exponents. So 2 plus 4, 7 plus nothing, 8 plus 3, 11 times 10 to the negative 5th. But, class, it's no good. Danielle, I'm only allowed to have one digit. I got 2. That's too big, right? So I move the decimal to make it. Now, what do I have to do with the exponent? I have to make it
Since you went this way, you have to make it bigger.
bigger. So what's
to the
bigger
negative
than
4.
Good. Negative 4 is bigger than negative 5, so that's my answer. All right, have a great day. Do well on the exam tomorrow.